I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, contributing in many different ways, providing suggestions, and some excellent questions. Based on your feedback, daily, almost daily, we provide you with an example of sharing passion with you, learning mathematics as we go along. Hope you're enjoying this journey. In this video, we'll talk about compound interest applications. You're familiar with simple interest, but to touch upon, we'll begin with simple interest and compound interest. How are they related? Then we'll take up compound interest concept. We'll talk about different compounding periods and how the investments grow. We'll also take up an example on continuous compounding. The rule of 72 is so much used in our financial industry. We'll talk about that. Doubling of money or investment can take place with the help of Rule 72. We can estimate duration of time. Present and future values, how are they related? How to calculate them? And then we'll solve some questions based on finding duration or interest rate given future present values. We might use logarithms to solve these questions. Now, interest rate reverse calculations is what I was talking about. Sometimes you need to use logarithms, and we have two examples where we are going to use logarithms. General formula for compound interest is given to you, and when we have continuous compounding, then the amount is P into E to the power of RT, where E is the Euler's number, right? So let's review what you really know about simple interest and how do we do the compounding over it. So simple interest is when you deposit a fixed amount, right? We call that as a principal. On this amount, you earn some interest, and the interest is amount times rate of interest times t. Now, this PRT is constant. So, basically, in your graph for the simple interest, when you invest, you have P, the principal amount. But as we go along year by year, what we notice is that it always is increasing depending on the rate of interest. So this increase is gradient, which is equal to PRT. Get the idea, right? So it is y equals to mx plus b, where the y-intercept is the principal amount invested. So that is a straight line graph shown here. However, when we talk about compounding, in that case, this interest which you earned in the very first year also qualifies for additional interest that is counted as a part of your investment for the next year. And therefore, because of that compounding of the interest, the amount is slightly higher than what you will get for the simple interest, right? So the general formula for the simple interest is amount is equal to P times 1 plus RT, and for the compound interest is amount A equals to P 1 plus R to the power of T. What I'm trying to say here is that compounding is exponential in nature, right? To the power of T, right? So it is exponential function. Perfect. So we are going to have now examples based on this. So let's begin with simple concept first. Here is the very first question which says find the amount of interest earned by a deposit of $1,000 for a period of 8 years. Now we have 6 examples here, right? So we'll begin from the very basic. So we have a deposit of $1,000 which is treat it as a principal, right? So principal amount is always what you invest, right? So it is $1,000. Now, for a period of 8 years, right? So time is 8 years. Time is normally mentioned in years only, right? Now, in the first case, what are we going to do is find simple interest at 5% per annum. Now, when I say 5% per annum, its decimal equivalent will be 5 over 100, right? Which is equal to 0.05, right? So, we'll write down that this rate is equal to 0.05, correct? Right. Now, this rate is same for both, right? Compound and also for the simple interest. Now, if it is a case of simple interest, let me write simple interest. In that case, interest is PRT. And in this case, principal is 1000, rate is 0.05, and the time duration is 8. So you can multiply and get the answer. So we get 1000 into 0.05 means 50 into 8, which is 400. So you get interest of 400, and all these are dollars. Now let's look into the compound interest, right? So I'm writing CI for compound interest. As you see, P still is $1,000. Time is again 8 years, and rate is also 0.05, right? Now, compound interest per annum, right? So it is that. The formula for compound interest is that the amount is P times 1 plus R to the power of time t. You get the idea? That is exponential function, right? So in this case, it would be 1000 times 1 plus 0.05 over exponent of 8, right? So that's fine. So we are first finding the amount, not directly the interest. You get the idea. So to calculate, we have 1 plus 0.05, that means 1.05, right? To the power of 8. And to this, we are going to multiply by 1000. So we have this amount as 1477.45. Correct. Now, what is the interest? Interest is amount minus principal, right? So amount is 1477.45, take away 1000. And therefore, the amount is 477.45, right? All the values are in dollars. So you can clearly see that simple interest earns you $400 for 8 years, whereas the compound interest gives you $477.45 in 8 years. So there is additional $77 because of the compounding, right? So you get interest on interest. So that is the reason for it. Correct. So here is the solution for you. You can go through this particular solution, understand what this difference is, right? So in our case, after 8 years, we found that the difference is 77.46, correct? Let's take up the next example, right? So the next example is based on compounding periods. Now, compounding could be yearly per annum, as we had in the last example, or it could be different periods, right? So we'll now talk about the compounding periods. Now, interest can be compounded more than once per year. So those are called the compounding periods. Common compounding periods N are listed here. So first is, of course, annual. So annual means once at the end of the year. So n is equal to 1. Semi-annually means twice, n equals to 2. Quarterly means 4 times, n equals to 4. Monthly means 12 times in a year. Weekly, 52 weeks, right? 365 are the number of days. Now here is a very special case, continuous compounding. So when it is continuous compounding, in that case we have a very different formula, which looks like A equals to P e to the power of RT. So continuous compounding means infinitely large number of times, right? Now it is very interesting to see how this is related with this formula, right? So you may learn later that actually speaking 1 plus R over N, right, to the power of N Where n approaches infinity, we say that the value approaches e, right? So we get this, all this is approaching e, right? Or it is equal to e. So that is the Euler's number, which is there in the formula, but the derivation we'll see elsewhere, not in this particular video. Perfect. So now let's take up an example which will help you understand how do we solve questions where compounding periods are different. So we have just taken four examples here. The question here is find the future value. So when I say future value, it really means amount. Okay. Find the future value of an investment. Investment means principal, right? At our 5% interest are after 6 years if the interest is compounded annually, quarterly, monthly, continuously. Correct. Annually means, as you know, n equals to 1, quarterly n equals to 4, monthly means n equals to 12, right? And here we have a special formula, which is this one, correct? Continuously, infinite times it gets compounded, and therefore this particular factor actually changes to e, right? Okay, so let's apply the formula and calculate our answers, correct? So the we know that a is equal to p times 1 plus r over n to the power of nt, right? If n equals to 1, in that case, our amount is equal to principal of 1000, right? 1 plus rate is 0.05 and t is 6 years, right? That is what it is, right? So 5, that means rate is equals to, in decimal, 0.05. You can calculate this value. Perfect. The second one, let's call about quarterly, right? So when you say quarterly, means n equals to 4. Apply and then find the value of a. So a will be now this time 1000, right? 1 plus rate is 0.05 divided by 4 to the power of 4 times t, 4 times 6, right? 4 times 6, which is 24. Okay. Monthly, for monthly, the amount will be same formula, right? 1000, 1 plus 0.05 divided by the 12 months, and this 12 is going to multiply by 6, correct? And for continuous, amount will be equals to 1000 times e. E can be found on your computer calculator, right? Use e, right? And RT. So R is equals to 0.05 and time is 6, correct? So multiply these two, get your answer, correct? Once you use your calculator, you get your answers. So we have applied these formulas here and shown you the value. Perfect. So when you're compounding annually, n is equal to 1, amount is 1000 times 1 plus 0.05 to the power of 6, and we get an amount of 1340.96. Clear? Similarly, when we use n equals to 4, the value is slightly higher. As you can see, it is 1347.35. So use your calculator to calculate these values. Now here the other two solutions where n is monthly means you're multiplying by 12, right? So 12 times 6, right? That goes into the exponent divided by 12. The interest charged per month will be 1/12 of the annual interest, correct? Makes sense? And therefore, you get the answer which is slightly more than what you got for quarterly. In the case of continuous, e to the power of rt, r being 0.05 and t being 6. When you do that, you get even higher value. So, those are the results which you get. So, you can see that continuous compounding will definitely provide you with higher values, future values, right? So, that is how we calculate the future values for different compounding periods, right? So, I hope this helps you to understand the concept. Here is example 3. Now, example 3 is we are relating the present value. We want to find the present value when you know the future value, right? Means, here's an example. Find the amount to be invested today, that is the present value, at 4% interest to be 10,000 after 6 years. You get the idea. So, amount is 10,000, right? So in this case, amount we want is 10,000 after the duration of 6 years, right? And interest rate is 4%, means 0.0. You get the idea. That is what we are interested in. And how do we figure out what should be invested? So that is rearrange the formula, right? So let's rewrite the formula itself, which is A is equal to P times 1 plus R over N, right? To the power of NT. So definitely, if I have to find P, I have to divide the amount by 1 plus R over N to the power of NT. Is that clear? You could use this formula to find the present value. What should we invest now to get 10,000 later? So we can now calculate this value. Amount needed is 10,000, correct? And we have 1 plus rate of interest 4%, right? 0.04 to be invested after 6 years. And remember, we are doing compounding annually, right? Therefore, n is 1, right? So n is 1, so I'm not writing anything in the denominator. And t is 6. So in this case, n equals to 1. So 6, correct? So you can calculate this, which is equal to 10,000 divided by 1.04 to the power of 6, correct? Let's calculate. So what we get is 10, 1, 2, 3 divided by 1.04 to the power of 6. So we get 7903.145. Let me write 1 5. So that is the value in dollars which we need to invest now at 4% compounded annually. So this is compounded annually to get an amount of 10,000 after 6 years. Perfect. You can check your calculations. Here is neatly done work for you to understand. Is that clear to you, right? Since it was annual compounding, right? So we have standard formula where n is equal to 1. Now we'll increase the compounding period. So we'll take up an example where the compounding is quarterly. Now, if the compounding is quarterly, now the similar situation is there. Find the amount to be invested today at 4% interest compounded quarterly to be 10,000 after 6 years. So the only difference here is that we need amount of 10,000, of course, right? In dollars, time t is 6 years, right? Now, n value is compounded quarterly, means n is 4, correct? And the rate of interest R is 0.04, correct? So, in the formula, you could also directly write down the values and rearrange. But what we want is the principal, right? So, principal will be equal to amount divided by 1 plus R over N to the power of NT, correct? So, principal is equal to 10,000 over 1 plus 0.04 over n. And since quarterly, we'll do this, correct? Over 4 times t is 6, right? So 4 times 6, right? 4 times 6. So which is 10,000 over. So this gives you 1.04 divided by 4 is 0.1. So 1.01 to the power of 4 times 6, 24. Is that clear to you? So we can now calculate this value. So 10,000 divided by 1.01 to the power of 24. And that gives you a value which is 7875.66. So it is definitely lower than the value which you got last time. You can compare, right? So that was last time's value, which was 7903, right? And now what you get is 7875. So slightly lesser amount to be invested now for the same conditions, mainly because it is compounded quarterly, correct? So here is the solution, work done for you, and you can now compare the values, correct? Easy. So as you see, the exponent is 24, 6 times 4. Now we are going to talk about doubling rule, very important rule which we come across. So the question here is, if $1,000 is deposited into an account that pays 9% compounded annually, how long will it take for the deposit to double? Now I say 9%, right? So what is, how do you, 9 times 8 is equals to 72, right? I'm just giving you this figure. Now we will see what answer we do get after the calculations, correct? Now clearly what is given to us is that the amount is to be 2000, which is double the amount because principal is 1000. We want to double the amount, right? We know the rate of interest is 0.09. We just want to find what is the time duration, correct? So we want to find what is t, right? So let's plug it in. So we have a equals to p times 1 plus r to the power of t, right? So amount is 2000. We doubled the amount, which was 1000 here, right? 1 plus rate of interest 0.09 to the power of t. We need to find this t, right? So when you divide 2000 by 1000, you get 2 equals to 1.09 to the power of t. Now, how do we solve for this t? To solve for t, we should take logarithms. So this is kind of important. So we get log of t, 2 is equals to log of 1.09 to the power of t. Now we are using log rules. Log 2 equals to t times log of 1.09. You can isolate t and t will be equal to log 2 over log of 1.09. Clear? Let's calculate. So logarithms is a function on your calculator. Just press log. This is to the base 2. You could use natural log also, right? So you get log 2 divided by log of 1.09, correct? And what you get is 8.043. You see that? So what you get is 8.0432. Is it clear? Do you see? So in approximately 8 years, you double. So with your rule, also we got the same answer. Do you see that? So we see that rule of 72 works, especially when we are finding doubling period and interest rate is annual, right? So that is what is required. So the period is doubling period is 8 years, right? So that is the approximate. The unit is slightly more, right? Perfect. Let's take up the solution which is shown here and same calculations which I did for you. So the important thing here is that rule of 72 helps. So most of the time you can find the value even without a calculator, right? Logarithms is difficult to calculate otherwise. Now here is the last example for you. Instead of doubling, we have tripling rate, right? The question here is if $500 is deposited into an account that pays 12% compounded weekly, right? So this is slightly different. We are compounding also weekly. How long will it take for the deposit to triple, right? So clearly what we have is that we have principal which is 500, right? And amount which is 3 times 500, right? 1500 you could write. Rate of interest are 0.12. I'm writing. Weekly N is 52, right? That is what we are doing. So now once again, the formula is A equals to P 1 plus R over N to the power of NT. So it is 3 times 500 equals to 500. 1 plus R is 0.12 divided by 52, right? And the power is 52t. Is that clear to you? Correct? So now we see 500 cancels. So we got 3 here. Let's take log. Right? So log of 3 equals to, we'll apply the rules. We have log of 1 plus 0.12 over 52 to the power of 52t. Right? So when you isolate, 52t can be written here. So let me rewrite. We get log of 3 equals to 52t times log of 1 plus 0.12 over 52, correct? So now we can say that 52t is equal to log 3 over log of 1 plus 0.12 over 52, correct? Or t is equal to log of 3 over log of 1 plus 0.12 over 52. And you have to divide by 52. Is that making sense to you? Now let's calculate, right? So basically, we'll just use the calculator log of 3, and then we are going to divide by log of, put within brackets, 1 plus 0.12 divided by 52, right? Bracket close, equal to. And then this number is being divided by 52, correct? And what we get is 9.16. So we could triple this money 9.16 years, right? Slightly more than 9 years. You can always convert 0.16 into months by multiplying it by 12. Making sense, right? So that is how you should be doing it. Now, here is how we are going to solve it. So, as I said, 3 times is 1500. So, we'll begin with amount as 3 times 500, 1500, and dividing 0.12 by 52 and the exponent also multiplying by 52. Rearrange and find the value of t using the formula. We get 9.16 years, which is approximately equal to 2 months. 9 years and 2 months will triple the amount in this particular condition. This makes sense to you, right? So, see, that is how we could actually solve few questions based on compound interest. As you have seen, we have discussed all these topics one by one, and we have seen how this formula of compound interest can be used under different circumstances. We also calculated the rate, sometimes the time period, sometimes apart from future and the present values. I hope you find this interesting and useful. Feel free to write your comment, share your views. In case you want to learn from me directly, you can send an email on the address given, globalmathinstitute@gmail.com. Thanks for your time and all the best.